Do you remember where you were whenever you realized this molecule was going to upend your life? This is the coronavirus spike protein, and it's responsible for the pandemic that we still find ourselves in right now. Scientists across the world have spent the last 2 years trying to figure this molecule out. They want to know, how does it move? How does it interact with other things? But I want you to imagine a world where all this effort wasn't necessary. Imagine instead that we had a computer program that was able to simulate this molecule using nothing but the laws of physics. Unfortunately, this isn't reality yet. And it's not reality because solving the equations of quantum mechanics for a molecule this big would take more time than the age of the universe, even on today's fastest supercomputers. Stop and think about that for a second. We've known the laws of quantum mechanics for over 100 years, and still, somehow, this is uncharted territory. The goal of my research is to use artificial intelligence, or AI, to learn quantum mechanics and make impossible calculations like this possible. Now, you can probably imagine that this is a pretty tough job, even for AI, but it's important to understand exactly why it's a tough job. It's tough because I just got done telling you that this model is much too big to do a calculation on. But every AI algorithm needs training data. So how are we going to train a model? We're stuck using an approach called fragmentation, where we take this big thing and we break it up into smaller chunks and then train on those smaller chunks. But this is a huge challenge for AI. Imagine I wanted to train a neural network to recognize cats in pictures, but I was only ever able to show it pictures of parts of cats, like paws or whiskers. The model would have no idea how those pieces of data are related to each other. So are we just out of luck? I think the answer is no, but only if we learn the right thing. And in this case, I think the right thing is the electron density. You see, unlike paws and whiskers, we know how the electron density on one part of a molecule relates to the electron density on another part of a molecule. So I set out to test this hypothesis. I trained a neural network to predict the electron density of very small clusters of water molecules, up to about 10. And then I asked that model to make a prediction on much larger clusters of 50 or more water molecules. And the result from that experiment was really surprising. The network that had been trained on the smaller fragments was able to make predictions on the larger fragments that were as good as if it had been trained on the larger fragment itself. And that's saying something really profound. It's saying that the electron density just might be the key to mapping between fragments and the whole. And if that's true, that's really exciting. Because if we can do that for water, then we just might be able to do it for whatever molecule causes the next pandemic. Thank you.